Hi, all my dear class 10 students. This is Rupa Guha, and we are doing chapter 10 of class 10. This is circles. We are doing the concept of this chapter. This chapter is contributing 6 to 8 marks in your final board examination. So let's get started with the concept part. Tangent to a circle. Now, a tangent to a circle is a line that intersects the circle at only one point. Now, in this figure, you can see that AB is a tangent to the circle and it is intersecting the circle at the point P. And this point P is called the point of contact. Now, let me take up the first theorem of this chapter, circles. This chapter has two theorems, and both of them are quite important and they are frequently asked in your final board examination. So, what does it says? The tangent to a circle is perpendicular to the radius through the point of contact. Means tangent is perpendicular to the radius. Now, let's get started with the theorem, how to prove this, right? So let me take a circle with center O. I have taken a circle with center O and there is a tangent, you can see xy, to the circle at the point of contact. Now what I need to prove? I need to prove that OP is perpendicular to xy. So what I have done here, so let me take a point P such that it lies outside the circle and I'll join that point Q. Let me take a point Q which lies outside the circle and I'll join with O. So OQ is a line segment, which is Q is lying on the line segment XY. Okay. So now you can see that OP is what? OP is less than OQ because OP is equal to radius and OQ is greater than radius, right? So I can take more such points on XY and join it with O. And you will see that all such points, the length of all such points from the center O is greater than OP. So what does it says? It says that OP is the shortest distance of O from the line segment XY. And we already know that any shortest distance is always considered the perpendicular distance, right? So that is why I would say that OP, that is radius, is perpendicular to the tangent, which is XY at the point of contact, right? So OP is considered the shortest distance and it is perpendicular. So OP is perpendicular to XY. So this is how you will prove that tangent is perpendicular to the radius at the point of contact. Now let me take one example. In the there is a figure, you can see that PT is a tangent to a circle with center O and angle TPO is 35 degree. I need to find the measure of X. I'll simply going to implement this particular concept that tangent is perpendicular to radius. So before that, this is a one marker from 2024. So I know that angle PTO will be 90 degree as radius is perpendicular to tangent. So using the exterior angle property for the triangle PTO, what I can say, X will be equals to PTO plus POT. Now both the angles is known to me, so I'll simply going to put the values and add both of them. So 90 plus 35 going to be 125 and the correct answer for this is your D part. So 1 marks nailed with this concept. Now I'll be stating a few facts about tangent. So the first thing about tangent is there is no tangent to a circle passing through a point lying inside the circle. So what I can say about this, that if a point is lying inside the circle, I cannot draw any tangent through it. Now the second point is there is only one tangent to a circle passing through a point lying on the circle. So now if the point is lying on the circle, I can draw only one tangent passing through that point. Now if the point is lying away from the circle. That is, I'll read it out and then I'll explain. There are exactly two tangents to a circle through a point lying outside the circle. So if a point is lying outside the circle, I can draw two tangents, right? So let me explore this fact with the help of an example and how these facts are going to help me answer this question. Let's see. So in the given figure, the figure is given here. You can see from which point can the tangent not be drawn to the circle with radius r. So there are two concentric circles. You can see that one is having the radius small r and the other is having the radius capital R. Now I need to pinpoint from which point I cannot draw the circle. This is a one marker question from 2024. Now I'm going to explore the facts which I know right now, which I have learned right now about the tangents, right? So I cannot draw a tangent from a point lying inside the circle. Now which circle I'm talking about? I'm talking about the smaller one because that is having the radius small r. So which point is lying inside that? Point y is lying inside that. So I cannot draw a tangent from point y. Simple, easy. So nail this question. D option is the correct option to this. Now, as I said, this chapter has two theorems and more or less one of the other theorem is usually asked in your examination. So you should be well versed with both of the theorems. So the length of a tangent drawn from an external point to a circle are equal. Just now we learned that from an external point I can draw at most two tangents, right? So those two tangents are equal in length. That is what I need to prove. See, I have drawn a figure here. So what is given in the figure? A circle with a center O and two tangents. Point P is lying outside this. So PQ and PR are two tangents and the motive of this theorem is to prove that PQ equals to PR. This is a very simple and an easy theorem. I'm going to take the two triangles and going to make them congruent. So which two triangles I'm going to take? Triangle OQP and triangle ORP. The first thing which I see is that OQ equals to OR. They are the radii of the same circle, so they are going to be equal in length. Now OP turns out to be common in both of them, and angle PQO and angle PRO are radius is perpendicular to tangent. So each angle turns out to be 90 degree. So these two triangles are equal and these two triangles are congruent by RHS rule. So PQ equals to PR by CBSE. So nail this theorem. Second theorem also nailed. So let's get started with the example which is based on this particular theorem. So it says in the given figure, आपने देख लिया एक figure दे रखा हुआ है, tangent PA and PB to the circle centered at O from the point P are perpendicular to each other. And it is given PA equals to 5 centimeter. I need to find the length of AB. So what is known to me in this particular figure? Before I decipher the question, let me see. It is a one marker from 2024. So now let's get to the solution part, right? So PA and PB, as I know that length of a tangent drawn from an external point to a circle are equal. So they are going to be equal. PA equals to PB. Both are of 5 centimeter. Now angle PAB is 90 degrees. So what I can use here? फटाफट क्या लगा सकते हैं? इस ट्रायंगल में पाइथागोरस थ्योरम लगा सकते हैं. PA square plus PB square will be equals to AB square. So PA and PB की वैल्यू 5 डाल दिया. So that makes AB square is 50. AB is 5 root 2 centimeter. Right, students? So with that, we nailed this question. Correct answer is your B part. This chapter is very simple. Mostly the questions are asked from NCERT. So go through NCERT properly and take care of all the questions from NCERT, even the solved ones as well. Okay, students. So I'll see you with my next video. Till then, bye-bye.